So instead of using the nmap, we'll use the rest scan. It's, it's way faster than the nmap. So rest scan followed by dash a, and then the IP, and then the dash u limit 5000. You can say u limit is the speed by which it scans. Then dash dash, then again dash a for aggressive scan, then output in normal format of rest scan all.txt file. So right off we see FTP open, 20 input, SSH and HTTP. So let's wait for this to finish. Okay, so it's finished. Let's see the results. We have 21 FTP, and right off we see anonymous FTP login allowed, so we can log in, and also it says that it's writable, so we can put folders on this share. Moving on, we have SSH. We cannot do anything since we do not have any credentials. We can try brute forcing, but we'll go into that later on. Then we have AT HTTP. So let's first of all enumerate the HTTP, and then we'll go for the FTP. It's the IP, and we see Apache 2 default page. Nothing special here. The webalizer tells us that it's 2.4.3 Apache. We can see the source code to see if there's any hidden comments. No, there isn't anything. So at this moment, I'll try to see if there's any robots file, robot.txt file. And we see that you're not a search engine, you can read my robots.txt file. So looks like it's searching if we are a search engine or not. So if you don't know what's a robot.txt file, then we can just search it. So it's a file that tells us search engine crawlers which URLs the crawler can access on our site. So basically, robot.txt file is kind of a sitemap. So the Google crawlers or DuckDuckGo crawlers go to the website's robot.txt file, and they see the index of the file, index of the website. So, and there are links that they can crawl, and those results will be displayed on the Google. So seems like it's checking whether we are a search engine or not. So let's try bypassing it. Let me turn on the proxy, verb, intercept on, refresh the page, intercept the request. Now you'll see the user agent is Mozilla 5.0 and Firefox as usual normal. So we can change it to Google or Bing. Let's change it to Google and forward the request. And right off we see that we have successfully bypassed it, and we can see disallow secret information. So we have found a directory. Let's browse into it, and we see DNS zone transfer tag and just some dummy text. Right up here we can see the page source, and we see a parameter language that is equals to en, that is for English, and es for Espanol. Spanish, not Espanol. Yeah, so we click on it and we see the text in English. We click on this and we see the text in Spanish. Perfect. So so the text is in Spanish. Now you'll see the parameter here, that is language equals to es.php. So it's fetching a file that's name is es.php file. So what if we try to include an other file in the Linux system? As usual, let's try etc password file, and we successfully have fetched the etc password file. So it looks like this box is vulnerable to LFI, local file inclusion. So we can view the page source and it's more readable. And we have FTP user and Tom user with the bin bash. So we can access into Tom, but we do not have the password yet. So it looks like there's only one user Tom. So we can search for bash, and if you see there's only 2 results found. Yep, only 2 results bin bash Tom. Okay, so let's try getting a reverse shell back. So there are a couple of ways you can get a reverse shell back. You can either do Apache log poisoning, since we know that this application is hosted on Apache. This web server is hosted on Apache, and so we can try Apache log poisoning. Another thing we can try is fetching the user's SSH key if user has generated his SSH keys. The third thing we can do is play with this box a little bit and enumerate it more so we can know what services are running and what we can take advantage of to get the reverse shell back. So let's do hidden trial and error. Let's do trial and error method. So first of all, we will try the Tom's SSH key. So it's Tom, I guess, yeah. Sorry, it's inside home folder, Tom users folder, then .ssh, then id underscore rsa, and we have nothing back. So looks like there's no file named id underscore rsa. We can try authorized keys. Oops, oh my god, I cannot type authorized keys. There's no authorized keys. There's no id rsa, nothing. So it looks like the user has not generated his ssh keys. So let's try something else. Let's go for the Apache log poisoning. So let's see Apache2 access.log. So here we are trying if we can access the Apache2 log files in its default location. So by default, Apache log files are located in etc folder, Apache2, and then the log file access.log. So we cannot access it either. So maybe the log file is stored somewhere else, or maybe the logs have been disabled in Apache. If that's an option, I'm not sure. So looks like both the methods failed. Now going back to the results, our recon phase, we see that there's a FTP login allowed. So let's go into let's log in into this FTP share. So the IP is this, enter the name as anonymous, and just press enter for the password, and we are in. We do ls, and we see a folder named pub, maybe that's for public. So cd pub, and we see the folder is empty. Now here, let's try uploading a file, so maybe we can access it somewhere on the web server. So then if we can access it, then we will try to upload our PHP reverse shell, and then we can get a reverse shell back. So let's upload a text file, simple text file. So put this, and it says transfer complete, and it's here. Perfect. So as you saw that there's a folder named pub, and inside the public folder there's this text file. So we will try to access it. Now we do public, then this, maybe scan all. Nope. Maybe this. Nope, not found. So it looks like we cannot access the public folder. Nope. Yeah, so it looks like we cannot access it. So but we can see the file has been uploaded on the server. So let's see where it has been uploaded. So we see that the FTP service running here is VSFTPD 3.0.3, right? So let's search in Google that default location of this on Linux. Now here is what is the default directory for VSFTPD, and we see the default VSFTPD login directory for the user is home directory of the system normal user. So it's basically in a default login directory for the anonymous user is var FTP. So it says var FTP. Let's see if we can access the var FTP. So var FTP, then public folder, and rust scan all.txt. And boom, we can access it. So taking a look at the page source, and we see our nmap scan here. Alright, so we have pretty good chances of getting a reverse shell back at this point. So this was the default location of VSFTPD. What if the default location has been changed and you do not know where the files are being uploaded? So in that case, what we can do is we can fetch the ftpd.conf file. I guess it's an etc folder, and ftp dot oh sorry ftp dot oh my god dot conf. Nope, I might be wrong. FTP configuration file. Let's see if we can find the FTP configuration file location here. And so it says it's in etc folder and vsftpd.configuration file. Let's try it. And yes, we do have a hit. Let's view the page source for the more readability, and we can see that it's a configuration file of vsftpd. So here you can see the where the files are being uploaded. So we can see anonymous root is in var FTP. So this is where the files are being uploaded. So this is one more way by which you can find where the files are being uploaded of FTP. Alright, so now as we know, so now we know where the files are being uploaded. Now we can try getting a reverse shell back. So let me know what's my IP. My IP is this. I have a PHP reverse shell ready. This pen test monkey PHP reverse shell. Now edit the IP. Port is 1234. Save it. Log into the FTP. So the command was, yep, here we have it. Anonymous, enter, cdpub, put php-rev.php, verify if it has been uploaded. Yes, it has been uploaded. Exit off of it, and launch a reverse shell. Sorry, netcat listener. Then we try to access it, and it's not responding, so it's a good sign that we have our shell back. And we do have our shell back. Perfect. Now let's try getting a TDY shell. We have Python 3 installed, so Python 3-c import pty.spawn. Oops, pty. Oh my god. Yeah, pty.spawn. Bin bash. Export term equals to xterm. So if you do not export, then you cannot clear the screen. Now you can clear the screen. Perfect. So now here, let's go inside the home folder, and we can see that we have Tom user. We go inside the Tom. Oops, yeah, and we have a couple of things here. So now our next target is to Prevesk and get the root privileges. So normally what I do is I look if there are any internal services running, any internal web server. So we do not see anything interesting here. The port 80 is for the HTTP, 21 FTP, and a couple more, but not the interesting ones. The next thing I do, I try searching for the SUID bits. So find slash dash permission dash 4000 2 greater than dev null, so it does not output the permission denied things. And we can see we have a couple of results, but these are not the ones which we can abuse and gain root access. But this one interesting result, that is home tom root shell. So it's a binary, custom binary that is not installed on Linux by default. So let's take a look at it. Here's the root shell. So we can see what it is. Root shell. Oops, it's filed root shell. Yeah, so we can see that it's a binary, elf binary. Elf binary means that it's a binary that can run on Linux, not on Windows. So on Windows you'll see it as exe, but on Linux you'll see it as elf. Okay. Now we know that it's made by C language because you can see the source code here, rootshell.c file, and here's it's the compiled version. Let's try running this and see what it does. Okay, so it's checking if you are Tom and you are www-data. So it was checking if you are Tom. So I suspect that if we are Tom, then we can get admin privileges because binary says root shell. So let's take a look at the source file. So cat this, and we have the source code. Okay, so this is the main function, and inside the main function we have printf checking if you are Tom. So it's checking if you are Tom user or not. So it opens the whoami binary. Sorry, it executes whoami binary, and the results that is given by whoami binary is stored on this user user variable, and then we see you are the whatever user we are, that is stored in this user variable, gets stored, uh, gets printed out. So as we saw here that you are www-data, so I was www-data, so that's why it said this. Now it's a comment, so we cannot do anything with it. Now if the user is Tom, then it will print access granted, and it will set our UID and to, I guess, okay, get EUID. Okay, so here if we are user Tom, then we do get a root shell back, then we get root back. Okay, so there's one thing that we can exploit here. You can change the path variable. So you can see that here it is executing the whoami binary. So where is the whoami binary in Linux system? Where is whoami? You can see the whoami is stored in user bin whoami. So we can see when this binary is being executed, then the Linux searches, then the binary searches for the whoami binary in the user bin whoami. So how does Linux know that the whoami is stored in the user bin? This thing is known as path variable. So the path variable is that if you execute anything like ls command or whoami or just simple id, any command, these commands are stored, these binaries are stored in the user local bin. Bin stands for binary, or in the user local sbin, or simply in the bin folder. So these binaries are stored there. So if you execute ls, the kernel, that is the Linux, you can say in simple words, searches for the paths that are stored in the path variable, and then it searches the ls command, sorry, ls binary in the sbin folder, Alright, then if it does not find it there, then it moves on to the user local bin folder. So it goes inside the bin folder and searches for the ls command, ls binary. So if it finds the ls binary, then it executes it. Alright, so we can take advantage of this, and we can manipulate the VMI binary with our own custom made binary. Okay, so I'll keep it simple. I'll go to the temporary binary, sorry, I'll go to temp folder, and let's make it as a screen first. Okay, so here we want mm, I'll say echo uh, echo ID to VMI. Okay, so we have made a text file here, which is VMI. So let's make it binary. Chmod plus x VMI. So now we have given it executable permissions. So now it can execute it. Now if we execute it, test slash VMI, then it says www test data. So if a root user executes it, then it will say root. Okay, so let's change our path to something different. We'll say as we know that the binary was searching for the VMI, so we will say export path equals to, sorry, it's export path equals to, we'll say temp, then colon, then our previous values that are stored in the path variable. Enter. Now let's see the path. So now the path is temp and then the rest of the stuff. So now what will Linux do is when you execute that root shell binary, it will first of all go to the temporary folder, and it will search for the VMI binary, and it will find it because we have created the VMI binary here, and we have our custom command here, that is id. So when we run that root shell binary, it will go to the temp folder, search for this VMI binary, it will execute the VMI binary and output the result of the VMI binary. It will not go forward for searching the VMI binary because it has already found, because it will already, because it already found the VMI binary in that temp folder. Okay, so enough talking. Let's see it in action. cd oops e dash plus, and let's execute the root shell, and it says successful that you are test data. Okay, so now it's using our custom made VMI binary. Taking a look at the source code again, root shell.c, we see that the binary is checking if we are a user DOM. So if we are user DOM, if the VMI outputs that we are DOM, then it will give us the privileged shell, privileged root shell. Okay, so you can see it compares the string user with DOM, and if it equals to DOM, then it will give us the root privileges. So it says access granted. So now we want our VMI binary to output DOM when we execute it. So we'll say echo DOM. Okay, so if someone executes the VMI, then it will say DOM. Perfect. Now we have our exploit ready. Now we can execute the root shell, and we will successfully get a root shell back. Root shell, and it says checking if you are Tom, access granted, and we have a shell back. Okay, so who am I? We are Tom. Perfect. So it is saying that we are Tom. That's because we have manipulated the path, and it's fetching the VMI binary that is stored in the temporary folder. So if we do ID, then it will say that we are root. Okay, so now we are super privileged user, we can do anything here. So I hope this video was somewhat educational and you learned something new. If you did not, then I'm sorry, and if there's something that I can improve on, then make sure to write it down in the comments. Thank you very much for watching. Have a nice day.